Hello, everyone. Thank you for attending today's webcast. This is a session on what's wrong with this picture. I'm Gary Klein with Gary Klein and Associates. I'll be the moderator and a presenter during today's presentation. We'll start this webcast with a few housekeeping announcements and then quickly move to our presentation. First and foremost, thank you to all of our sponsors and ACEEE, ally members for their support of the Hot Water Forum and of ACEEE. Be sure to check out all the tabs on the left-hand side of the app. From there, you can network with attendees and program participants, visit sponsor pages, and engage in our game to possibly win a free registration to the 2023 Hot Water Forum in Mission Hills, California. The resources section includes the program and a list of attendees for downloading. Lastly, we ask everyone to please help in our planning of the future Hot Water Forums by completing the conference evaluation. Anyone who completes the evaluation and includes a testimonial will receive a $25 discount off their 2023 Hot Water Forum registration. Unfortunately, because this session is being recorded prior to the start of the Hot Water Forum, we will not have the opportunity to answer questions live. However, we encourage you to reach out to us with any questions or information you have to share. We can be reached by messaging us in the Program Participants tab on the left-hand side of your page or by reaching out by email. We will share our email during the presentation. So I'd like to introduce the two of us who are speaking today. I'm Gary Klein with Gary Klein and Associates. I've been in hot water for about 30 years. My co-presenter today is Larry Weingarten. He's been in hot water for the better part of 50 years. And so with that, you can read our actual bios online. I encourage you to do that. Let's get started with some troubleshooting. Are you ready, Larry?
I'm ready.
Cool. You should all be seeing our first slide. We decided to call this presentation "What's Wrong with This Picture," in large part because Larry and I have spent much of the last 2.5 years doing troubleshooting virtually because of the pandemic. We haven't done much traveling. And we keep finding things that ought not to be wrong, but are. And we wanted to share with you some of what we've seen in the last few years and show you how we dealt with these problems. And, if you have any insights, please let us know. If you see things that we didn't see, that would be great to know. So hot water throws some interesting curveballs. Here's some examples and what we did. The troubled hot water knows where Gary and Larry live, right? And we're going to show you some of the jobs we've been asked to help out with. You'll notice there's some common themes, but first, Larry, why don't you talk to this slide?
I really like troubleshooting. One of the basic premises of troubleshooting is you cannot make assumptions or prejudge. You just have to suspend all of that, gather up the facts. Part of gathering up the facts is seeing what's going on in the system, not just outside, but like we wrote here, water flow and heat transfer. Changing your time scale and seeing that block of rust build up in the dielectric union or scale holding the swing check valve open. These are the things that we need to time travel and see. Figuring out tests for the different parts of the system also is part of the fun of this. How do you know what's wrong? How can you test for it? And there's more.
That's true. There is more. So, Larry, one of the things that I've noticed is that doing troubleshooting virtually is really a challenge because it's really hard to stand back and take the right picture.
Yeah, it's not just visual either. I like to actually put my hands on pipes, feel the temperatures change, feel motion of water in them, listen to it, gather information in a lot more than simply visual ways, which infrared cameras are a great way of doing this. That's a really fun tool. I've found even in relatively simple systems, if you make a schematic so you can see things like convective flow, hot water floating on cold water, stuff like that, it really helps to get a mind's eye picture of what's really happening. Oh, sorry.
So I'll take over for a bit here.
Yeah.
We have spent a lot of time using our various tools, and we've engaged our clients in helping us gather data. And only after we gather a bunch of data is it time to actually get to the point of diagnosing what's wrong and planning to what needs to get fixed. So with that, let's go to our first job. The first one here is a group living situation in San Bernardino, California. They have a heat pump water heater installed in each of 2 closets in each of 4 buildings. So there's 8 heat pump water heaters installed in this project. They're all in closets that are too small for the manufacturer's recommendations of space around a heat pump water heater. And so the problems that were given to us when we started, they were not getting enough hot water. There were high energy bills. There was inconsistent plumbing and inconsistent temperatures of hot water coming out of the water heater. And so we went to the job site. We were asked to participate by some folks in San Bernardino, and they went and looked at the job site, and we watched virtually. So they took lots of pictures. And what we found in this particular closet, there were 24-hour recirc loop running. That's sort of a no-no with this style of heat pump water heater. It's not designed for that purpose. We noticed that the plumbing, if you look carefully here, you'll see all the plumbing comes out of the water heater on the left, but it goes into the plumbing system on the right. You can't see that yet, you will soon. And you'll also notice that there's a duct going into the top of the water heater coming from the ceiling above. So Larry, you're a plumber. Do you see the airflow here?
Well, it's coming in from that duct, unconditioned space if it's from the attic, and then it's leaving it's exhausting into the conditioned space in the smallish room.
Yes, there is an undercut under the door, by the way. And one of the tests we did before I ever got to see the place was to see how wide you had to open the door so there was no pressure differential between inside and outside the room. And it worked out to be the door, a 4+ inch opening all the way around the door is what caused it to balance out. So that's a big undercut, let me tell you, like half a door.
Yeah.
And so I think that this brings us to one of the points that we are wanting to share and discuss some later at the end, is that heat pump water heaters have a third thing you need to pay attention to. It's not just connecting the water and the electric in this case, or the gas in other cases for gas water heating. It's paying attention to the airflow through the heat exchanger that makes the hot water. It has to be accounted for. And it's one of the critical things we keep seeing wrong in a lot of installations.
And in this case, if we're going from inside to outside, then if it's windy, it's imbalanced.
Oh, it's even more fun. I think we'll get to see that in a second. So we were able to get some funding to put in some flow meters and temperature gauges, and we got some recording flow loggers, and we hooked everything up. It looks like a bit of spaghetti, but all the plumbing is where it was in the first place. And we've attached temperature gauges and flow meters to the various parts of the system. We have 4 different flow rates, and we are able to start paying attention to how much hot water is being made each day and what proportion is coming from the recirc loop versus the actual draws by the tenants in the building. And so we did a bunch of things, and we did them in some order based on what we were learning. We engaged energy saver mode. The original heat pump was set up in combined mode, and we made it so that it would go energy saver as opposed to running resistance only, and that cut the energy consumption down a bit. Then the second thing we did is based on our observations of the airflow, we rerouted the inlet duct, which was coming from the attic. We rerouted it to come from above the big refrigerator in the kitchen, which was right next door. and we made a nice louver above the door so we could increase the exhaust area so we'd get balanced flow in and out. And so we did that, and it didn't make any difference at all, as we can see a little later in the energy numbers, because it turns out they leave the door open most of the time anyway. So that didn't make a huge difference. And then we moved the equipment over to the Building A laundry, which is the other closet with a heat pump water heater in it in this building. That room is even smaller than this one, but fortunately that heat pump has a timer-based recirc loop. And so it shows different patterns. And then round 3 of what we ended up doing was to change the control for the circulation pump toward the end of January. We were watching what the differences are in the energy terms. You can see the temperatures going up and down, Larry. What about those here?
Well, circ loop, your constant slow heat loss running out of a recirculation loop. So that was drawing it down.
Yes.
And it wasn't.
That's what's happening.
Yeah. So that's can you tell me how many degrees that sawtooth is showing?
Roughly 105 to almost 135.
Yeah.
About a 30 degree.
Yeah.
Yeah, it's a big delta. And it's basically the heater came on, it reheated the water in the tank, and the temperature decays. And then it heated it again, and then the temperature decays. And then it stops decaying so much, and it goes down here. Then it goes up again. It goes down again. Right here, no use. It's great. This is classic. And when it drops faster, there's uses. When it drops slower, there's no uses. It's pretty amazing. The data loggers are really helpful at figuring out what's going on. Watching temperature alone is helpful. Having the flow rates telling you how much water is moving is even better.
And 105 is right at the bottom of usable hot water temps.
Well, it's a good thing that the water heater knows to kick on and reheat at that point, because otherwise it would be annoying.
Yeah.
So that's one of the problems with the inconsistent hot water temperatures. This way the system was set up, that every few hours the temperature would just decay down to 105, then it would rapidly come back up again, then it would spend the rest of the day decaying, and it just keep repeating the cycle. All right. Let's talk about this slide here. You can see right over here that in the first case, right, what we saw is that the 88% of the energy was coming from the resistance elements, which were technically only operating 14% of the time. And the heat pump was only providing 12% of the energy. And that's a big deal. It's supposed to be the other way around. Okay. And that's what we're trying to figure out. Why is this being crazy? And now at the moment, this is where we're at right now in this job. We started working on the project in early September. We made the first change, which to go from resistance to the middle control mode, the energy saver mode. And there's varying occupancies across this time pattern. And then late in the year, we go into this yellow time pattern, and the energy use keeps going up and up and up. It's obviously colder weather, so you'd sort of expect that for the hot water demands, not for the recirc loop. We made some changes in this time frame, as we talked about, for controlling the airflow. We don't see any changes at all in that process. And then in January, right here, we changed out the controls for the recirc pump. And you can see pretty clearly that even though the weather's cold, and even though I think the occupancy is very similar, the pattern of energy use has come way, way down since we changed the controls for the recirc loop. All right, let's keep going. So we fixed the airflow, we changed the recirc strategy, and we've gotten better hot water temps and greatly reduced electrical usage. That was what we were trying to figure out, and we'll see how it goes from here. We haven't had much feedback recently.
In this case, do we have sort of a fraction? What percent of total energy use is actual use? What percent is recirc?
Not off the top of my head, Larry, but we do have the data for that.
Okay.
recirc was the recirc was probably 60-70% of the actual energy.
Yeah.
If my memory serves. All right, let's move on. Now we're going to go over to Weston, Massachusetts. This is a large single-family home that I was fortunate enough to be asked in to help with the design of the hot water system before they did all the work to plumb it. I've known the developer for a decade or so, and he reached out and we helped with the basic design. We designed this house to be all electric. Because of the size of the house, we picked a heat pump with a finishing tank so that we'd have plenty of hot water. For houses of this type end up getting run sort of like small hotels, lots of people visiting all the time, and you have to plan for peaky issues. And we separated the home into 3 plumbing zones, which you can see here, 1, 2, and 3, going to different wings of the house so that it wasn't just one really big recirc loop, which would have had to been run all the time. By separating it out, we can prime the lines with hot water. So that was the plan. And so it has recirc loops, and that was what we planned. And so after construction's done, I get a call from the developer, and he says, I've got too much energy use, and the temperatures are weird, and it takes forever for the hot water to get around the loops, and what's going on? And so we did some investigation to try and figure out what's going on. Larry, you've asked a question here about, is there enough heat pump airflow? This is an almost perfect installation for a heat pump water heater. It's in a basement in a somewhat dampish summer climate, right? And it's in a big open space in the basement. It's got way more than the 700 cubic feet that our manufacturer wants to see. And it's a great location. And it looks like the air can come in from the top and exit out the side without much trouble at all.
Good.
All right. What else do we see here? Oh, yes. So on the right-hand side, you can see the heat pump with the buffer storage tank. They're both from the same manufacturer. Larry, the one on the right's a Rheem Marathon. That doesn't have any anode rods in it, does it?
Not. It's a polybutylene lined fiberglass tank with 3 inches of foam. So it is, if not the best insulated, it's one of the best. They lose anywhere from 5 to 7 degrees over 24 hours.
It's great. And it's a good match for the Rheem heat pump water heater. It's always a good idea to have products from one company sitting in your system so that there's no finger pointing if there's a problem. I think it helps to have it that way. What I want to show you on the left-hand side here is that when we got into the mechanical room, you can see that we switched from PEX going in and out into the ceiling, going to the rooms, to copper in the mechanical space. And one of the reasons we did that and we recommended that is that copper has very little pressure loss per fitting compared to the insert fittings used in PEX. And mechanical rooms often end up with a lot of fittings, as you can see here. And there's lots of reasons to change direction in relatively short distances. And so every time you put a fitting in, fittings cost you something with pressure loss. In order to keep the pressure losses to a minimum, we recommended switching from the plastics to the copper as we're in the mechanical space. And they did a really nice job of laying everything out here, don't you think, Larry?
It's pretty, yes. And it's at a good working height. A lot going for it.
Yes, they thought about it carefully. Do you know what this is here, Larry? In the center here, with the red line across?
I would be guessing.
Nope. It's a pressure pump. They're augmenting city water pressure here in the house, and that's the whole thing that does it. It's a very nice little unit.
Okay.
They've made some adjustments to water pressure in the house, and it's made some improvements to performance, and that's not a bad thing here. Over here, there's the, what is that? That's the expansion tank. Any comments on that, Larry?
I'd like to see it up a little closer, see if there is an eye isolation and bleed valve above it. But
If there is, it's real hard to see, isn't it?
yeah, it's pretty tight there.
I don't think so. The red thing I saw in the last picture was the valve here for draining, but not for the
Yeah. So
expansion
that,
tank.
and if I'm going to nitpick, I'd say the plumbing has to take any weight that tank has when it's half full of water.
Right.
Which, yeah, but
so I like the insulation job here a lot. I'd rather that figure out how to put the clamps that hold the pipe up around the insulation rather than underneath it. These are minor details. It's not the major cause of what's going on in the house. So we were able to get some analysis because the developer has good tools for diagnostics, and lots of energy stuff is being monitored in this building. And we found out that while they paid great attention to detail of insulating the pipes in the mechanical space, he went back and looked at all the pictures that were taken, and it wasn't so good on most of the loops. So there's much more heat loss than expected on the loops. The other thing he was able to do is to measure the flow rate of the pumps on each of these existing recirc loops. And he found out that the flow rate was very, very low. Okay. And it wasn't supposed to be that. He selected pumps without discussing it later on in the job. I guess we forgot to specify at the beginning quite clearly, and it just didn't quite happen right. So we ended up having to put in higher head pumps with better controls on demand as opposed to timers that were being pulsed. The pumps have good check valves in them that were preventing the flow, that prevent flow in the loops that aren't calling for hot water. In the first case, the one pump would induce flow in the other two loops so that all of them were losing heat at the same time. And the buffer tank was added early on in the design phase as part of increasing heat pump performance and capacity for the house. It's trying to make a big system out of a slow heating system. All right, let's move on to Sacramento. I got a call from a friend who said, I got a buddy that's on a project that's had problems. Can you come look at it? Okay. And I go over to this apartment complex not too far from where I live, and they have lots of complaints. They have inconsistent temperatures in one or two of the apartment buildings. They have these heat pumps, which are very large commercial units installed in closets that are, in one of the cases, the closet is just about big enough for the water heater to fit in. This is one of the bigger closets. It's, I don't know, 5 foot by 8 foot, something like that. And this is a change out from a gas water heating system for these apartment buildings. Oh, there's a recirc loop on there. Do you see the pump down in the corner, Larry?
Yeah.
Over here?
Yeah.
24/7.
Wonderful.
And the control feature for the pump is a ball valve to slow the flow rate down. And I really like the configuration of the plumbing up here. What do you think?
Used to hook up there.
Yeah.
A gas heater, and they didn't clean all that up when it was changed out.
Yeah. So all of these, what don't look like big deals, end up making life miserable when you're trying to figure out what's going wrong, because this should have been cleaned up as part of the install. And that's, I guess, one of the other points that Larry and I have found is that if you treat a change out from an existing water heater to a heat pump water heater as a simple change out, it isn't. You have to pay much more attention to doing the work and understanding what the issues are going to be before you do that. So what else? What did we end up finding here? Larry, what are these all about?
Moen, crossover valves. These are the cartridges for shower valves. And Moen and some other brands are sort of infamous for that. The older style ones often would leak between hot and cold, allow water, even when they're shut off, water can flow from cold to hot or vice versa.
Right.
And They have since come out with more modern cartridges that don't do this, but these are some of the older brass ones.
And so one of our recommendations to fix some of the problems was to basically get rid of the crossover, which was eating up a fair amount of the energy in the system, probably about 15–20%. And that's the kind of stuff that can make or break a system working well. And so they went in and they did a replacement on it one day where they went through all of the apartments in one building and made these change outs and saved all the bits so we could look at them afterwards and see what's what. This was a very helpful exercise, and it made a noticeable difference. Not enough to fix everything, but it was a good start on the problem.
Yeah.
The biggest issue turns out to be the airflow. So the closet on the left is a wide closet. It's got 2 doors in it, so that means it's an 8-foot wide closet, probably 5 foot, 6 foot deep. And the airflow, the original installs didn't have any airflow built into the doors, just what was there for the old gas water heater. Not enough. So they put these in, and you can see it's a rough and ready way to get the install in to work. And what they ended up having to do is to put the grill you see over here on the right in front of where the heat pump fans are, so that it would blow straight out. And if you look carefully, you can see here in the background, they made a collar around the front of the heat pump. So when the door is closed, the air has to go out through the door. That turned out to be a really innovative solution they came up with to make sure that air went out one way and air came in from other ways, and it didn't mix in the middle. Worked out really well.
Because otherwise you're going to get mixing. You're going to get cold air from the heat pump getting sucked back in, lowering the efficiency. Right.
All right, so we found and removed some crossover in the plumbing. We did some work to manage the airflow around the heat pumps. And we still haven't resolved the question of why the recirc loops are running as fast as they are 24/7. But this is an old plumbing system. In fact, there's one building that's served from the mechanical room in another building, and the piping goes underground across the courtyard, 50-ish feet back up into the apartment building. And who knows if it's insulated underground, right? There's a lot of heat loss going on there, and they're not going to be able to resolve all issues. But we're not getting complaints, so that's good. All right, Clovis, California. All right, our 4th project is in Clovis, California, single-family home. I was involved with this project early on because of wanting to monitor the energy use of the water heater as part of another project. We helped with the basic design and selection of what's going on here for the hot water system, but mostly it was up to the builder to put everything in for new home construction that's going all electric. And so, Larry, let's look at this system. We got called because there was not adequate hot water at the taps. And later we found out that the recirc loop would go to 0 flow when the tank was hot. That didn't get noticed for about 2 or 3 years. But nonetheless, we got called in. So what do you see here?
Well, looking at the pump, if a bubble of air got in that, how could it get out?
What do you mean?
Well,
the water return is coming in over here on the left.
It then goes up to the pump, over, keeps on going, then it goes down back to the heater. So that's an air trap.
And the pump won't work if there's air in it, right?
Centrifugal pumps don't like air.
There we go. And then I've been listening to you for many months now. This the expansion tank doesn't have a way to actually set the pressure.
It's way too common that people don't put in a shutoff valve and a bleed port on these things. Expansion tanks are like magic to lots of people.
Yeah, I get that.
Yeah,
Um,
they don't get that they have to be pumped up. You need to carry a gauge and then pump the tank up to match whatever your line pressure is before it's hooked up to the system. That often isn't done. And the maximum pressure they can be shipped at is 40 psi. Department
there we
of
go.
Transportation rules.
So the other thing I'd like to note is that the insulation is nicely taped together so it doesn't split, except you'll notice that it's a little tight. It's got corsets everywhere. The point
Yeah.
of the insulation is to get the wall thickness. It is, in my opinion, much better to have a thin amount of insulation installed correctly than a fat amount installed wrong. This is sort of halfway in the middle. It's not a very good job. It's pretty complete, but it could be better.
Yeah.
And there's a master mixing valve here too, which we'll come back to later. Do you know why this had a master mixing valve in this project, Larry? Did we discuss that?
I don't know that we did. I assume they're looking for scald protection.
Actually, they put it in the master mixing valve because this project was one of the ones that self-selected to let the heat pump be controlled for peakiness for the electric utility. So they could raise the temperature in the tank during off-peak hours and use hot water during peak hours and not run out because at a higher stored temperature.
Okay.
And even though it's not exactly clear in the plumbing code when that has to happen, at 140, above 140 degrees stored hot water, you want to put a master mixing valve in for scalding, in addition to the valves that are at your showers, for example.
Right.
And then over here, you see these check valves. There's one check valve here. There's another check valve here, right? To make sure that the pump, well, nothing goes backwards. The pump has its own check valve in it. So why there's an external one, I don't understand.
So more flow restrictions.
Yeah, and this check valve that's here, it's really interesting. That check valve creates the need for the pressure tank, doesn't it?
Okay, so that's your cold supply down at the bottom, and there's nowhere for the hot water to expand back if that check valve is there.
Yeah.
Yeah.
Now, Larry, you like these flex connects, don't you? The stainless steel ones.
Yeah. Yeah.
Yeah.
I like them
Better than
because
the copper,
they
right?
do. Sorry?
Better than the copper ones, right?
Well, they're easier to work. Stainless doesn't work hardened the way that copper does, and at this point they cost about the same, and they're a full flow kind of connector where some of them have restrictions built in. The braided stainless ones I'm not fond of.
No, we want full flow. Let's not reduce pressure when we don't have to. There's enough trouble already.
Yeah.
All right. So now we're looking at what we found and what we fixed. Step one is over here on the right. We'll come back to step two. Step one is that we recommended that they tilt the pump so that there was no chance of an airlock in the pump itself. There's going to be an airlock bubble. It's going to be up here somewhere out of the pump, and it won't stop the pump from moving water. And so by putting it at a roughly 45-degree angle, it was possible to make that happen. And we rerouted the plumbing going back up and down through. The reason it has to go up and down all this time is because we got to figure out how to measure flow rates, and we need a straight section to measure the flow rates in. This is the solution we worked out with the space involved. All right. The other thing is you'll notice that there's no thermostatic mixing valve, master mixing valve any longer in this project. And after a long time of trying to diagnose what was going on, we actually asked the owner to take a picture of the master mixing valve label, and it says 1070 XL. And we went and looked up the manufacturer's model and brand, and we find out that this is a triple listed master mixing valve. Well, 1017, ASSE 1017 is the standard for master mixing valves. And it is very clear that it's designed for flowing water coming out of a water heater at the beginning of a hot water distribution system. The 1070 standard, also from ASSE, is for mixing valves near sinks and tubs and such things. And it's designed to be a temperature limiting standard to a maximum temperature, in this particular case of 120 F. And so every time the system got to be 120 F, it's relatively cool hot water for people who want really hot water. And two, when it hit 120 F, it would stop the recirc pump from pushing water through the system because it wouldn't let it happen anymore. It was too hot now. Oops.
Great.
And so this turned out to be the cause of both of the problems that were in the house. Not hot enough hot water and the pump turning off. Now, we solved the minor problem in the middle, which is the airlock of the pump. You shouldn't build pumps with that potential in them, install them in that way. And so this is the fix. I would observe that I really don't like having the recirc loop pipe come all the way down to the bottom. I would rather have the pipe, because it's coming on a one-story building, up and coming out near the top of the wall. So I have choices about where to bring it on my way down into the system. That would have solved all these problems in the first place and actually cost a little bit less to build. So, oh well, moving on. Next project. What did we do? We got rid of the airlock. We got rid of obstructions. Everything looked pretty good. The tenant is happy. The owner's happy. Oh, I got a call the other day, Larry. I don't know if I told you. It turns out that the T&P valve was blowing off water, and he couldn't figure out why. So he eventually was able to reach the manufacturer, who said, well, your expansion tank's probably failed. He fixed the expansion tank and everything's working right. The T&P valve is no longer doing all the protection work. And then he said, well, the pump isn't working. And so over the phone, we diagnosed that he hadn't drained the water to recharge the system through the pump and out the little valve over here on the right. He drained it over here on the right of the tank. And of course, it didn't actually do anything to get the hot water loop running. So you have to make sure that you prime hot water pumps, recirc pumps with hot water.
And it's good that there's a hose bib on this line, so that can be done.
Yes, it is.
And you see that yellow handled shutoff valve underneath it, so that can be closed, and then that bib opened, so you actually can force all the air out of the plumbing.
Yes. The only thing that you and I would quibble about with mostly at this stage is that there's not enough ability to undo and redo parts, except by bringing a torch to the job, right? We would prefer to see a bunch of this stuff in threaded pipe rather than in soldered or crimp pipe.
Yeah.
All right, moving on. Next one, Los Altos, California. This is a recent job for us, but an old job for the problem. Larry, why don't you take this one for a bit?
Well, this one, they built the house 18 years ago, and it never really performed well. They couldn't get cold water, a very strange thing, but they used to have solar, and thought maybe that's some of the trouble. They took the solar thermal out, didn't fix anything, but you see the clues, that large blue expansion tank down at the floor, and we'll show you some close-ups of some other valves that were not working right. And it's when you put the pieces together wrong that you get trouble. If you trace that pipe up from the expansion tank and see where it goes, it's going into the wrong pipe. So when people would use cold water, this forced hot water into the cold side.
Real here.
Yeah. There's you can sort of see that swing check valve
right there.
Yes, and of course it's slightly hard water. Swing check valves get stuck open. Clearly, people had played with it. The top of the check valve had all kinds of wrench marks on it, but there's no long-term fix for that other than to put a spring check in.
So, and the check valve is before the plumbing for the water heater, so you can't actually shut it off and do any fixes. they're in the wrong position.
Yeah.
Shut off valve to the right, check valve to the left in this case. This is
Yeah.
the cold water feed for the whole house.
Yeah. This
And
wasn't designed to be easy to work on.
no, you think? High efficiency water heater. 18 years ago, this was pretty much state of the art for gas water heating. It's a great choice.
Mm-hmm.
Nice water heater, big house, bunch of bathrooms, planned for lots of people to visit. And you know what? The grandkids started showing up, and that's why they finally called and got us to come out and look at it. We know the people who gave us the recommendation because of work on other projects. And so they did a nice job of labeling things. This has been torn apart a few times since, so it's not the perfect job when it was originally installed. But we spent time diagnosing it. We tried to figure out if there were crossover issues. Again, I think the biggest thing we've learned to check for crossover, Larry, is there has to be a way to remove the expansion tank, if there is one, from the equation. Otherwise, all you do is spend 15 or 20 minutes in this case waiting for the expansion tank to bleed out its water, and then you find out nothing happens.
Right.
So things we learn when we diagnose. This was the fix that ultimately got done, right, Larry?
Yeah. So where your arrow is, there's a check valve. There's a spring check there that's new. That there had been a spring check there that was limed open, corroded and limed. It had this nice blue-green stuff all inside of it and was basically just a piece of pipe. So that could have been a source of a crossover. But
Right.
it turned out that wasn't the big deal. If you see that white handled valve underneath that ball valve, just behind that lever, you can make out a spring check. So by having that valve
in the
there,
union and the wall valve, there's a spring check, so you could actually repair stuff without taking the whole thing apart.
yeah, no torch needed now.
Good. This is the cold water feed for the whole building, the whole house. This side of the house, there's 2 water systems in this house. And now this pipe is actually cold. It wasn't when we got there.
Yeah.
And they were having inconsistent temperatures at the showers too, because this line would be full of hot water. So if you send hot cold water and hot water to a mixing valve at your shower, it really doesn't know what to do because it doesn't have anything to delta T with. It has to have that. Larry, did we add this drain here too? We did add this, didn't we?
Yeah. Yeah.
There wasn't a bleeder. This is the kind of stuff that drives Larry and I nuts. There has to be a way to make sure everything is primed and working properly, and then it has to be able to go in and assess what to do next if there's a problem. Oh, Larry, you got to talk about this one.
Yeah, I mean, so you see that gauge. That by the way, is saying that there's about 60 psi. But if you follow the pipe over, you'll see that it's cut. There's clearly no pressure in the pipe. That's just sitting there. So it's hard to trust gauges, even though that's a nice oil-filled gauge, but it's lying. Oh,
Yeah.
well, it's one more stick in the works.
And
so
I think this is the big deal.
Yeah, this is what they wrote to us. So this is nice.
It's a great thing. And so far, everything seems to be doing what we hoped it would do. There's still the other hot water system to work on. We haven't got to that one yet.
Yeah.
6-1, Woodside, California. Single family home. Great view that doesn't end. Overlooks the Pacific Ocean. It's absolutely gorgeous. Notice the pretzels for plumbing.
Yeah.
I think they could work for some bagel shops and donut shops in the U.S. This is great. Let's make pretzels. So convoluted plumbing. We see 2 recirc pumps. That looks all fine. They originally installed a heat pump water heater for this house, which they tore out almost immediately because it never made hot enough water or not enough hot water. And the call to us was, we have a small amount of hot water need per, there's only 3 of us living there. So in electric terms, it's probably going to be, if it's heat pump, 150-ish, if it's resistance, $450 a year for hot water, plus minus some numbers like that. But it was costing, when we did the math, way over $5,000 a year for hot water, because the recirc loops are running all the time just to try and keep the water hot near the fixtures. Well, what's going on here?
Yeah.
So Larry, this was a project we actually got to go look at in person.
Yeah.
And we looked at a bunch of stuff online in advance of going to the job site. And here's what we found.
Yeah.
We had an IR camera with us. They had added a return line in the ceiling because part of one of the bathrooms hadn't been connected to the recirc loop when they built it. Notice that it's a really well insulated pipe. Not.
Yeah.
We should be able to see
heating.
it. Yeah. This is in the ceiling. We're looking up and there's this hot spot in the ceiling. It's like, that's a recirc return. Okay. But what's going on over here, Larry?
Well, they had put sleeves in, the red and blue sleeves, because that way which one is which. We hope they got the colors right, but those are going into the concrete. And where's the insulation? I guess the plumber thought that sleeve would insulate as well as real insulation would, but not the case.
Not the case.
And these are going deep into concrete, right? There's a sub area, and then a slab on top of that. So there basically is no real opportunity for access to this buried stuff to redo it without tearing much of the house down.
Yeah, the diagnostics, thank goodness they had videos and pictures of construction that we're able to see in our diagnostics. They were invaluable at figuring out what was going on. But basically, the piping ended up getting installed in the slab, attached to the rebar every so often so it would stay put, with a red sleeve or a blue sleeve attached to it. There was no pipe insulation on any of the hot water distribution piping except what you could see in the mechanical room, and that was about it. And it was losing all of its heat under the ground. And so it needed to be fixed. The problem is there's no attic in that house. It's all cathedral ceiling everywhere. Nice modern look. And so we ended up having to find a way to get from the mechanical room up, out onto the roof, over the roof, down into the 2 different wings that can't be reached from that part to fix the kitchen in one of the bathroom areas. The other bathrooms were able to be fixed from inside the envelope, and rerouting the loop to make sure that it would all work right. Instead of 2 loops, we ended up with 3. And that allows us to prime the system better and everything works correctly. But there's an awful lot of semi-exposed insulated hot water piping now up on the roof, but there was no way to get underneath the slab to fix anything. That was just a non-starter.
Right.
And IR pictures are fun. So you can see a warm dog, sort of. The nose is sitting there right in front of us, and it's cold. Healthy dog.
The dog stays cool.
Yeah, it's great. All right. Chicago. Brand new home built to Passive House standards, following Passive House guidelines and rules as best everyone could figure out. And it was a nice heat pump water heater. This is a split system, and it's about a 43-gallon tank in this case. And nice clean lines of plumbing. Everything looks straightforward and neat and tidy. And so they had inconsistent hot water temperatures and really long wait times for the hot water recirc pump to prime the line. And, it wasn't working right. And they couldn't figure out what could be done to fix it. So they reached out. we evaluated the floor plans. We had the owner measure time to tap for hot water. We talked about rerouting the plumbing. We tried a crossover test. We installed new storage tanks. We ultimately fixed a whole bunch of things. But in our diagnostics, we figured out that they had built the loop sort of backwards. Water heater is roughly at the corner of an L in the shape of the house in the basement. So it's in the center, but there's two wings of plumbing, one going to the bedroom wing, one going to the kitchen wing. And they had made one really big long loop with 2 or 3 sections in it, which were 50-foot long spaces where there's no fixtures to the next fixture, which is a really long distance between fixtures on a recirc loop. And so we reconfigured the layout in the basement to make it into a 2-zone plumbing system so that we could shorten the time to tap on each of the zones. Yeah. Right? What else, Larry?
Yeah. Well, just this photo is here so you can see that there's no way to charge or deal with that expansion tank. There's no valve, no bleeder, nothing. So the whole system was like that, very short on valves.
Yes, it was extremely short on valves. We tried to do a crossover test, and what we finally figured out is there was no shutoff for the hot water line. The only shutoff for the hot water line was to shut off the cold and hot to the whole house. So there's no way to actually do a crossover test if you can't shut off one side of the system versus the other. Nice, clean lines and plumbing, great layout. Everything looks neat and tidy. The problem is it's not repairable without coming back with a torch. It's not diagnosable because there's no shutoff valves, no isolation valves. It really needs help. So we spent a lot of time going back and forth to come up with the schematic. The owner was going to do the project management for the job because it was, more than a year after the house was built. There's a lot more isolation valves, which the conversations we had with the plumber were some version of, I don't want to put all those valves in. And it's like, we need them to make the system work, right? We have to be able to isolate components. Yeah, okay. And ultimately did a great job of doing all the work. Great pleasure to work with them. It just took a while to get past why do we need all the valves. And we ended up making heat traps out of the flexible connectors to prevent heat from going in and out the wrong way. And we'll show some pictures of that in a minute. It's a 2-zone plumbing system. Everything is diagnosable and serviceable, and we made sure they only put in an ASSE 1070 valve so we don't have the temperature limitation issues. And the results, they now have good hot water temperatures. We got rid of the inconsistencies in this. And we've done some corrosion protection measures. We've reduced the time to tap. It used to take 1.5 to 2 minutes to prime the loop with hot water. Now it takes 15 to 30 seconds. There's 2 loops, one time, one the other. It's doing exactly what it was supposed to do in the first place. What's really interesting, though, is that we still have a problem. We have a thermosiphon loop on the heat pump side of the system. Go back to the schematic here. The right-hand side is domestic hot water use. The left-hand side of the heat pump, the storage tank, is the heat pump side going outside. And in scale, the actual heat pump sits outside above the top of this tank, probably at ground level, right about here. And so we're still seeing heat coming out of this tank, going up outside and coming back colder. We've got a thermosiphon loop going on. Yeah. So there's no check valve, and it does need to be addressed. And so we're working with the owner to fix that next. These heat traps work on the hot water use side, everything, which is what this is showing. Everything is working correctly. The heat does not go past the trap on either side, and there's no obstructions in the waterway, and it does exactly what we expected it would do. It's not quite doing what we hoped on the other side yet because there's an induced flow, but we'll fix that and it will then work correctly.
Yeah.
So let's wrap this up, Larry.
Yeah. To start with, though, if I can ask another question, how do we educate all the plumbers out there? How do we get some sort of continuing education going so it's not a strange idea to them to have isolation valves and threaded joints or, access working space? This has been a problem I've seen. Is it just part of the bidding wars? Cheapest bidder wins? There's some way to fix this?
We're going to have to work on that. Each state has rules for continuing education. Each state has training. Some states have, well, the union has training. The Plumbers Union, United Association, trains apprentices and has been for a really long time, and it's a great program. But not everyone comes to plumbing that way. And a lot of what we're talking about is not part of standard practice, although it's no reason it shouldn't or couldn't be.
Yeah.
So I'm hopeful that this presentation will get watched by a lot of people because it's a good start on learning how to think through this properly. Troubleshooting teaches us how to do things right.
Yeah.
So we do really need to wrap this up because of time limits here, but modern heaters are not a simple swap out. There's different connections in different places, and you have to manage airflow. Heat pump water heaters have to be specially understood. Recirc loop losses can be much bigger than expected. Larry, this is one of your favorites. Hot water is a system.
Yeah, you have to see the whole thing. You can't focus simply on one component. You have to look at how it affects everything else.
Yeah.
That makes people happier in the end.
Yes. And we need to make sure that systems are designed and built so they're easy to maintain. Insulation really matters. Heat pumps do more of the work and work better with more storage because they're currently relatively slow recovery. We have to understand that in the way people use hot water. We have to make sure that when we're designing systems, we account for the run times of the heat pumps to keep up with the expected use rates.
I would just throw in that as we are as electrification is taking hold, heat pumps are going to be a bigger and bigger piece of the pie. So we really all plumbers need to understand how heat pumps work.
Yes, we do. All right. I think with that, we're going to wrap it up and thank everybody for attending. And I have one more thing to do here. Thank you for this conversation, Larry. I enjoyed having the time to speak with you today.
Thank you. Oh, if anyone wants to contact us, maybe the next,
There we go. Here's how to find us if you want to. We'd love to hear your stories and figure out how to work with you to troubleshoot and build new ones right. Thank you for your time.